Hello, my dear students. Welcome to the next session of Semiconductor chapter. In this session, we are going to learn about the MCQs, the multiple choice questions, which is there in the last end of the chapter in the textbook. So the first MCQ is in a BJT. BJT stands for bipolar junction transistor. Largest current flows occurs. Largest current flow occurs. So current, it is actually depending upon the number of, it depends on the number of charges, right? More is the amount of charges, more will be the amount of current flowing through a device. So among this emitter, collector and base, what do you think, which one is heavily doped? So the answer is emitter. So since emitter it is heavily doped, I can say more amount of charges are present in the emitter, such that more amount of current it is flowing through the emitter. So the answer is option A. So I told you that emitter current is how much? In the explanation theory, emitter current, if suppose it is 100%, the collector current it is 95 percentage, and the base current it is around 5 percentage, right? Such that emitter current it is equal to collector current plus emitter current E, i.e. it is equal to collector current plus base current IB. Okay, so this is actually the answer. A option, option A is correct. Let us now move to the next MCQ. You all are requested to please note the solutions. So next MCQ is this: a series resistance. Series resistance means RS. This series resistance it is also called as source resistance. This series resistance is also called as source resistance in the Zener diode circuit. It is connected in the Zener diode circuit. So for what purpose this series resistance is actually connected in the Zener diode circuit? The first is properly reverse bias the Zener. So is this properly reverse biasing the Zener? So Zener diode circuit is always in the Zener diode circuit. The Zener diode is always connected in the reverse bias condition, or it is used to protect the Zener diode, or it is properly forward bias the Zener diode. Forward bias of Zener diode is not actually happening in any of the cases. Why? Because the Zener diode has to be connected in reverse bias condition in order to operate as a voltage regulator, or to protect the load resistance. This is not the thing in which the source resistance or the series resistance can be connected. If suppose I consider a circuit diagram of Zener diode acting like a voltage regulator, this is the supply. So this is unregulated voltage source. Unregulated voltage source. This unregulated voltage source is actually the output of the filter circuit. It is connected to the source resistance Rs, or I can say the series resistance Rs. Then the Zener diode it is connected actually in the reverse bias condition like this. So this is the Zener diode which is connected in the reverse bias condition. This is positive, this is negative. This is positive, this is negative. Negative is connected to positive terminal, positive is connected to negative terminal. That means it is the reverse bias condition, right? So Zener diode in the reverse bias condition acts like a voltage regulator. This is the load resistance RL, and whatever is the output we are getting here, the output actually the plus or minus VO it is actually the regulated voltage. So this is the regulated voltage. So this we are getting is the regulated voltage. Okay. Now a series resistance is connected in the Zener diode. So for what purpose this RS it is connected? So if suppose if I consider the Zener diode has some specification. For example, IZ maximum. What is IZ maximum? IZ maximum is the maximum current which can be flow through a Zener diode. If suppose that the current through the Zener diode exceeds this value IZ maximum, then the Zener diode may get damaged. Okay, so in order to protect the Zener diode from getting damaged, the current flowing through the Zener diode, that means the IZ value, should always be lesser than this IZ maximum. Now, this RS is selected in such a way, if suppose no load is connected to the Zener diode circuit, that means all the maximum current will be flowing through the Zener diode, this RS is selected in such a way that the current through the Zener diode will not exceed this IZ maximum. Okay, so that means the RS it is actually selected in such a way that it will protect the zener diode from getting damaged. Okay, so what is the answer? The series resistance is connected in the zener diode circuit to actually protect the zener diode from getting damaged. So that is option B is correct. Okay, let us now move to the next MCQ. LED emits visible light when it's actually LED is a light emitting diode which emits infrared light or visible light, okay, in the forward bias condition. And moreover, the intensity of the light from the LED it depends on the forward bias current. Okay, so LED emits visible light when its junction it is forward bias. So junction is reverse bias. This option is not correct. Depletion region widens. So the width of the depletion region will increase. Let's suppose the junction is reverse bias. So again, reverse bias condition is not happening. Holes and electrons they recombine. So this is the correct option. Whenever the holes and electrons are recombining in the depletion region, that will result into the light from the depletion region, and that's by that way you can say infrared light or visible light is coming out of the depletion region from the light emitting diode. Junction becomes hot, so this is not the answer. The light will not be getting emitted except for the junction of the uh, LED is getting hot. Okay, so holes and electrons they actually recombine in the depletion region, and this is the reason why we are observing a light from the LED. Okay, a particular photon it will be getting generated from the depletion region of the light emitting diode. The next question is of solar cell. Solar cell operates on the principle of. Now, the solar cell, the materials of the solar cell, the materials of solar cell, it is made up of photosensitive material. Okay, so this is photosensitive. Photosensitive. What is the meaning of the photosensitive? Photosensitive means, suppose this is the material, this is the photosensitive plate. So this is the photosensitive plate, and if suppose the light of particular frequency or energy it is getting incident on the surface of this photosensitive plate, what is going to happen is it will start generating the charges. It will the electrons or the charges will be getting emitted from its surface. So this is the property of called as photosensitivity. Okay, and this is present in the photosensitive material. So solar cell it is actually made up of photosensitive materials. That means whenever the light it falls on the depletion region, the holes will be formed. Also, the free electrons will be formed, and the free electrons will be getting accumulated in the N region, such that the number of free electrons in the N region will be increasing. Holes will be getting accumulated in the P region, such that the number of holes in the P region also is going to increase. So that means the cell is getting charged, positive is becoming more positive, negative is becoming more negative, and that means it can be used as a DC power source. Now, if suppose we connect an external load to a solar cell, so it will be acting like a voltage supply, okay, a DC power supply, and the current will be flowing through the external load from positive to negative, right? So this particular photosensitivity, it is also called as photovoltaic action. This is also called as photovoltaic action. Okay, so this is also called as photovoltaic action. So solar cell operates on the principle of photovoltaic action. Okay, so that is option C. So option C is correct in this case. Next question is logic gate is an electronic circuit. So logic gate is an electronic circuit which what makes logical decisions or allows electron to flow only in one direction. So it is actually the normal PN junction diode. The second one is the normal PN junction diode. Normal PN junction diode, which allows the unidirectional flow of current. Works using binary algebra. Binary algebra means the language of 0 and 1 or alternates between 0 and 1 value. So that means the things 1, 3 and 4 are correct. It is matching with the logic gate electronic circuit. But what is the logic gate stands for? Logic gate stands for example, this is the block which contain logic gate. So it can be a NOT gate, it can be an OR gate, AND gate, NOT gate, NOR gate, exclusive OR gate. So it may have many inputs. It may have many inputs. So this is the input side, but there will be only one output. There will be only one output. So What is implemented inside this logic gate? This is the logic. Okay, and as per the logic, it will give one decision whether the output it will be high or it will be low. So the logic gate is an electronic device which makes logical decisions. This option is correct. Option A is correct. Okay, so this means option A is correct. Which alternates between 0 and 1 value, you can say it may be considered as inverter or NOT gate. They will be talking about NOT gate, right? So this might be one reason. Okay, so this is all about the MCQs. The next topic that we are going to learn in the next session is actually the unsolved numericals from the textbook. Thank you so much, all of you, for paying attention. Keep learning. Goodbye. Take care.